Hey, what's up, guys? I think I'll do a quick run through of the STAAR test from 2015. This is for Algebra 1. So we're looking at the STAAR Algebra 1 test administered in May 2015. So let's go ahead and run through this and see if we can see anything. I want to show you some calculator techniques to get through the test here that might be useful. So let's go have a look. Alright, so we're looking at the first question here. Alrighty, and I can't see it all, so I'm going to zoom out this way. Alright. And the first question here, it says the scatter plot shows a number of visitors to a beach each day and the high temperature in degrees Fahrenheit for that day. Alright, so let's get this pen working here. As you can see here, we have temperature on the bottom and the number of visitors right here. Keep in mind, it's worth noting, this is the independent variable. That's always what the x variable is. It's independent. And the dependent variable is the number of visitors. So as we typically say, y depends on x. Whatever this variable depends on this variable. So it says here, based on scatter plot, which statement appears to be true? There is a nonlinear correlation between the high temperature and the number of visitors on the beach. Well, I don't really think that's true. If you look at these points, they kind of follow a linear pattern. You can sort of draw a line through most of them, where some of them are on top and some of them are on bottom. This is fairly a linear pattern, so I'm going to say that's not true. Okay, I'm looking for the one that is true. I say that is actually kind of a linear pattern. B says when the high temperature is above 100 degrees Fahrenheit, fewer than 150 visitors are expected on the beach. So it does, as you notice, that the temperature doesn't actually go much further. Right here at the very end, that would be 100 because they're going up by 5s. 95, 100. But at 100, if I follow kind of where this line was, I'm expecting basically a turnout like this. So I'm gonna trace from 100 and trace back over here, and I'm going to expect something around 240 or 210, somewhere thereabouts. Definitely more than 150. This says fewer than 150, but I'm going to say, that 240 is not fewer than 150, so this is wrong. It says there's no correlation between the high temperature and the visitors on the beach. So this answer says there's actually no relationship between temperature and visitors. It's pretty common sense. If the temperature is increasing, you can see that the visitors are kind of going up gradually. So that doesn't make any sense. There is a relationship. There is a correlation. So this leaves the last answer. When the high temperature is between 75 and 90, then I'm expecting more than 120 visitors. So here's 75. Okay, so we'll go up to my line. And 90, that's the second temperature they give me. So 90. And I'm going to come over here. So I'm expecting somewhere between 120 and maybe like 180 people. And I'm expecting more than 120. That's true. Between 120 and 80, I'm expecting somewhere in this ballpark of number of people. So definitely more than 120 right here. Somewhere between 120 and 180-ish. So this is actually the only reasonable answer that you really have. So the answer is D. Alright, number 2. Let's actually zoom in on this. This is actually kind of a tricky question. A man bought X boxes of donuts for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, which inequality represents the number of boxes of donuts he could have bought? I want you to keep in mind here that X represents the number of boxes. Each box cost $3.49. Okay, so it's $3.49 per box. That's how much you're paying. $3.49X. This guy's paying with a $50 bill. So he pays $50, so that's what he gives the clerk. The clerk will keep the money owed to him, which is $3.49 per box. And then whatever's left, $50 minus what the clerk keeps, is what change he gets back. So this is equal to something. This amount, though, is somewhere between 10 and 20. So he receives more than 10, but less than 20. So what I actually have is an inequality here. All right, so this amount here is actually going to be, let's erase that. Where's my eraser? Okay, a man bought X boxes of donuts for $3.49 each. He paid with a $50 bill and received the correct amount of change. If he received more than $10 but less than $20, which inequality represents the number of boxes of donuts he could have bought? Alright, so you're talking about the number of boxes of donuts. This is X. This is the number of boxes. You have X boxes of donuts. This is what he's paying for each box, $3.49. So logically, $3.49 is being multiplied by the number of boxes. It's $3.49 per box, and this is the number of boxes he's taking, right? He's paying with a $50 bill, so this is how much he gives the clerk, all right? The cashier, $50, and the clerk will keep whatever's owed him, which is what? $3.49 times the number of boxes that the guy bought, all right? And whatever's left is going to be the change from this. This change that he's getting is somewhere between 10 and 20. It's more than 10 and less than 20. All right, so what I'm going to actually come out and say is that this is the change. It's $50 minus what the clerk keeps. So this is the amount of change this guy's keeping. This value is going to be greater than, this is going to be greater than his $10, but it's going to be less than $20. So the amount of change is between 10 and 20. That's what it says here. Okay. So now what I'm going to do is basically solve this equation for x. There's actually two equations here. All right, so let's solve this for x. And what I'm going to do is subtract 50. Try to get x by itself. I have to get rid of this and get rid of this. So I'm going to subtract 50 from every side, both the left side and the right side and the middle. Take 50 away. This is going to be 0. 10 minus 50 is negative 40. And 20 minus 50 is negative 30. So let's consolidate what we have here. On the left side we have negative 40. In the middle we have this left over. So don't forget this inequality. We got 349x, and then we have less than negative 30. Now the idea is to find x, okay? So I'm going to have to get rid of this. This is x times 3, negative 349. The opposite of multiplying is to divide. So to get x by itself, I have to divide this by negative 349, this by negative 349, and this side by negative 349. It is worth noting that a negative divided by a negative is a positive, okay? So all of these will be positive. But because I divided by a negative, these inequalities, both signs here, need to be flipped over. So this is going to turn this way, and this one's going to turn this way. And what I'm going to have here, this is going to cancel out here. All I have is x in the middle. So x is going to be between something and something else. So let's figure out what negative 40 divided by negative 3.49 is, and negative 30 divided by negative 3.49. So I'm going to make the calculator do that for me. All right. So I have a trusty dusty calculator. I'm going to open up a calculator window, and I'm going to say divide. So control divide. I need to figure out what negative 40 divided by 349 is. I'm sorry, negative 349. Let's make that a negative. Don't forget that. Do it just as it says. That's going to be $11.46, somewhere thereabouts. For the other one, it's going to be negative 30. Let's do a control divide again. Control divide will give you that nice little fraction. So this is going to be on top here, negative 30 divided by negative 3.49. And that'll be $8.60, we'll say. So 1146 and 860. These are my lower and upper boundaries here. So 1146 and 860. Let's go back to the problem. All right, so this is going to be 1146, and this is going to be 860. So what I'm declaring then is that x is actually greater than 860, but it's going to be less than 1146. All right, so another way of writing this is to say that 860 is less than x, which is less than x, and x is less than 1146. So let's check these answers out, see if anything looks like this. If x is greater than 860, then it definitely could be 9. It could also be greater, x can be greater than 8 as well. So this is all fine for every one of these, okay? But where we're going to have a problem here is that x has to be less than 1146. All right, well, 11 is in fact less than 1146, but 12 is not. 12 is not less than 1146, so we can't actually say this is correct. We have to get rid of the answers with the 12 maximum. So we're looking at this and this. All right, now keep in mind that x has to be greater than 860. All right, and we have to choose between this answer and this answer. The reason I can't choose 8 is because the value between 8 and 860 is like 820. Okay, if I choose this here, it means x could actually equal 820, but that's not true because x has to be actually greater than 860. So this is actually not correct. The answer, the only answer that really makes sense now is F. This is a kind of a challenging question, I'm not going to lie. It's not one of my favorites there, but the answer is F for that one. That's a definitely intermediate to difficult question. Let's come down to number 3. This one's a little simpler. In fact, this is very simple. You'll have some easy questions on this test, and you'll have some challenging questions on this test here. So let me move this out of the way. It says the graph of a quadratic function R is shown on the grid. The quadratic function, as you well know, makes a parabola. That's what this U shape is called. It's called the parabola. They're saying what is a solution to the graph equaling 0? All right, this graph will equal 0 on the x-axis. Wherever this graph crosses the x-axis, that's where it is equal to 0. That's where the y value is 0. So I have a coordinate here and a coordinate here. This coordinate is -6, 0, and this coordinate right here is 14, 0. So the y value, this is the same thing as the y value. The y value is equal to 0 here and here, and they don't want to know what the solution is, so they're asking you for the x value. This x value is -6, this x value is 14. Which one of these two values is a solution? The answer is 14, because -6 is actually not in our answer selection. So that's the answer for this question, number 3. All right, let's move on. Okay, number 4, the function y equals 6 plus 1.25x can be used to find the cost of joining an online music club and buying X songs from the website. Based on this information, which statement from the graph of the situation is true? All right, I really want to compare this equation they've given me to the equation I know well. The equation of a line that I know well is y equals mx plus b. All right, the y here is called the dependent variable, the depth var. M is called a slope. X is called the independent variable. And B is called a y-intercept. Now if I write this equation that they've given me here, it's the same thing. Okay, I'll write this as y equals 6 plus 1.25x. Now if I write it in this form, I'll have y equals, because that's what I have, y equals mx. There's a number times x. This number is 1.25 times x, so it's 1.25 times x plus some other number, that's plus what? 6. So I'm going to write it this way. Okay, your y is your dependent variable. And what is your dependent variable? What does y mean? This equation is used to find what? To find the cost. This is the same thing as your y. So this here is your cost. This is your slope, which is your rate of change. Two things are changing, x and y. Okay, let's actually figure out x here first. X is an independent variable. Online music club buying how many songs? X songs. So X is the number of songs. So this is songs. This is a slope, the rate of change of Y and X. And this is the price per song. Per song. So what I'm telling you here is that the slope is what? The price per song. That's what the slope means. The y-intercept, of course, is the what? It's going to be some sort of fee that's tacked on to using this. Okay? It's actually the cost of joining an online music club. They're charging you $1.25 per song and then plus $6 to join. This is the cost to join, sorry. Alright, so let's figure out what all this means. The y-intercept of the graph represents the cost of the song. No, what does the y-intercept mean? The y-intercept is this number, and this number is what? The cost to join. So no, that's not true. The cost of each song is actually what? The cost of each song is called the slope. So this is wrong. The y-intercept of the graph represents the cost of joining the music club. The cost to join the music club is this number, and this number is in fact the what? The y-intercept. That is true. Okay? It costs you $6 to join the music club, and then what? You get charged $1.25 per song. This lone number, though, is the cost of actually joining the club. This is actually correct. Okay? Let's go through the other answers. The slope of the graph represents the total number of songs bought by the members. X is the total number of songs. What is X? X is an independent variable. It is not a slope. Slope is a number, which is what? The price per song. So the slope of the graph represents the price per song, not the total number of songs. This is wrong. Remember, the slope represents the price per song. It says the slope represents the number of songs. That's not true. The slope is the price per song. We already know that. This is wrong as well. So your answer for this one is G. This is basically, do you know your sense around the word problem here? All right. Oops. I need to go back here. Skipping a question. Scroll down. Okay. I'm quite fond of these questions. And the reason is they're giving you 5 figures in a pattern below, and each figure is made up of identical circles. So there's lots of circles here. If the pattern continues, which expression can be used to find the number of circles that make up figure n? So n, they're calling figure n. This figure is 1. So they're telling you n right here, this n value is 1. Okay? This n value here is what? Is 2. This n value is 3. N value is 4. And this n value is 5. All right. Okie doke. So let's take a look at this. I'm going to make a table here. I'm going to have n, and then I'm going to have number of circles. These are going to tell me the number of circles, these expressions. So let's take a look at figure 1. If I have 1 for n, how many circles do I have? 1, 2, 3. All right. If I have n is 2, then I have 1, 2, 3, 4, 5, 6, 7, 8. So n is 2, number of circles is 8. If n is 3, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3, 15, and so forth. All right, so we don't have to do the whole thing, but let's take a look at these answers. If I have this expression here, I'm telling you n squared plus 2n. Okay, so I got some number squared plus 2 times another number. And what is n for this value? Let's say n is 1. So I'm going to plug in 1 for these n's right here. What is 1 squared? That's 1. What is 2 times 1? That's 2. What is 1 plus 2? That's 3. Does this number match this number? The answer is sure. Now we're going to do this again. We're going to change this number. Okay, this number here, we're going to change it to a 2. So 2 squared plus 2 times n. All right, 2 squared is 4. Oh, wait, what is n? N is 2, we're saying, so this is 2 times 2. So 2 squared is 4 plus 2 times 2, which is also 4. 4 plus 4 is what? 8. Does this number match this one? The answer is yes. Let's try this one more time. 3 squared plus 2 times 3. We're just substituting 3 in for these n's right here. This is going to be 3 times 3, which is 9, plus 2 times 3, which is 6. 9 plus 6 is 15. Does this number match this one? The answer is yes. So this actual solution is in fact A. Okay, it can't be any of these other ones just based on looking at it. Okay, if I plug in 2 for this equation, this is 2 squared plus 4. That's what? 4 plus 2, which is 6. Is this a 6 right here? The answer is no. We can keep doing this for the rest of them, but you're going to find that none of them actually work except for A. So let's go on to the next question. All right, number 6. One wall inside a shoe store is used to display walking shoes and running shoes. We have 2 types of shoes. We have walking shoes and we have running shoes. All right. There are 135 pairs of shoes in this display. So W is the number of walking shoes I have. R is the number of running shoes. So I'm going to take all my walking shoes, add all of my running shoes, and how many shoes do I have on the display? A total of 135. So all the running plus all the walking equals 135. I've created an equation. There are 1.5 times as many pairs of walking shoes as there are running shoes. So the walking shoes is the same thing as the running shoes times 1.5. That means there's 1.5 times as many walking shoes as running shoes. To find that, we multiply R, the number of running shoes, by 1.5, and that's the number of walking shoes. What I've created here is 2 equations. In an algebra, 2 equations is referred to as a system. Okay? The great thing about systems is that you can solve them in a calculator. The calculator command for the Inspire is menu 3, 2. So let's check out the Inspire, and we're going to plug in these two equations in here. Okay, so this is 1.5. All right, so let's go. Okay, so we're back to our calculator here, and what I'm going to do is go to Menu, Algebra, Solve System of Equations. There are two equations. My variables are W and R. It says X and Y, so I'm going to delete these and change them to W and R. So I'm going to hit W, comma, R, and then hit OK. Now the first equation I gave you was that all the walking shoes plus all of the running shoes equals 135. So I'll put that in there. W plus R equals 135. The second equation that I wrote down says that W is equal to 1.5 times R. So times R. Now when I hit enter, it's going to tell me W and R, the number of walking shoes and the number of running shoes. So as it turns out, the number of walking shoes is 81 and the number of running shoes is 54. So let's go to the answer. 81 pairs of walking shoes and 54 pairs of running shoes. That's what the calculator told me. There are no other answers that come close to that, so the answer is J. The calculator did this pretty much for you, except you have to create a system first and then solve it. This is actually an intermediate to difficult question. This is not easy to do for a lot of students, is creating this system, but with practice you can get better at it. All right.